In this video, we're going to discuss the measurement system model and specifically what a zeroth order model is. So, in general, for a measurement system, we have an input signal. All right, so this is due to the change in the process around the instrument. All right, and then sometimes we also have the initial conditions of the instrument itself, and those will affect the output signal of our from our measurement system. So, um, so essentially, in most measurement system cases, we can approximate this relationship between our initial condition, our input signal, and our output signal using an ordinary differential equation. So in general, we can write that general ordinary differential equation, right, using this term here, using this equation here, right? Now, this looks like a very intimidating equation, but keep in mind that we just have our input signal, f of t, right? And we have our output signal, y of t, here. All right, and then all the other terms in this equation are constants, right, that are known, and they typically represent physical properties, okay? So we can determine all the A and B terms, all right, and as long as we know the input, we can simulate what the output of our measurement system should be, okay? So for a zeroth order system, which is what we're interested in for today's class, is that we are interested in basically when we take this large equation up top, and I'll change my marker color here, and we're going to eliminate nearly all of the higher order terms. Okay, so we're left with, in this case, all right, basically just this equation here. All right, we can rearrange this equation slightly, all right, where we basically can say that our output of our sensor is just going to be equal to our calibration constant, K, capital K, times our input signal. Okay. So, all right. So the nice thing about zeroth order systems is that they have instantaneous output. All right. There's no delay between the input signal and the output signal. All right. And we can use this model to analyze any system, any measurement system, and it doesn't matter if it's first order, second order, or zeroth order, under static conditions. So if we have a non-changing input, we can use the zeroth order model to model any of our systems to determine or at least our initial calibration constant. Okay, so over this lecture, we're going to discuss two measurement systems that can be modeled as zeroth order systems, which are strain gauges, all right, and load cells. In both of those cases, the input signal is strain being applied to the gauges, all right, within the strain gauge, or in the case of a load cell or torque cell, is also being strained, and that's getting converted to electrical resistance. And that electrical resistance is what we can relate back to either strain, force, or torque.